Hi folks, William Lane here from Nightingale Science. Today I'm going to be giving a quick demonstration of how to get up and running on our platform, as well as how to use the platform to inspect the data that we provide, as well as do interesting things with it, such as machine learning. So the first thing you need to do is you need to go to app.nightingalescience.org. That'll take you to this website, which you see here. And the first thing you're going to need to do once you're here is register. And to do that, you just click this Register Now button. You fill out some basic information about yourself, as well as information about any institutions that you're affiliated with, and someone who can verify that you're affiliated with that institution. And you read and understand and agree with our terms of service, and then you click Register. After you've done that, we on the Nightingale side need to approve you, and we try to do this as quickly as we can. Most approvals are done in less than 24 hours, so it should be a pretty fast and painless process. The only thing that we really need to insist on is that your use case is non-commercial. So if you're a researcher, that's great. If you're someone who wants to explore the data in a genuine scientific capacity, that's also great. So just just make that clear when you register. Once you've registered, you can click Login. I've already registered, obviously, so I'm going to do that. I'm going to click Login. We use two-factor authentication, so I'm just waiting for my code here. Okay. Got it here. I'm going to submit the code, and I am logged in. So after logging in, you'll be at this project screen. You can see all the projects you're associated with, and a project is basically it is a collaborative environment. So you can create a project to access the data. You can save notebooks there. I'll talk about that more in a minute. And you can add members who have also registered for the platform to your project, so you guys can work collaboratively. As you can see, I have a number of projects that I'm associated with. For demonstration purposes, I'm just going to be using this Nightingale Data Team one. Once clicking that, it'll take me to this instances page. And instances are computers running on Amazon's cloud. So you can see them here. If this is the first time you're doing it, you need to create a new instance, give it a name, give it a description, give it a size. We provide extra small CPU instances for free, but after that we have to charge, and that's not because we want to make money off of you. That's just because that's what Amazon is charging us, and we're a nonprofit. So take a look here, and I'll note as well that we do have GPU instances. Currently, we only offer this NVIDIA Tesla T4 GPU, but we're working on expanding the options as soon as we can. So in the coming weeks, I think you should see a few more options there. I already have a GPU instance running, so I'm going to go ahead and connect to that. Close that tab. Okay, and this is what you should see when you first enter our platform. On the left, you'll see this file browser. So we see data sets, we see project, we see a tutorial notebook that I'm going to be using in a minute, and logs. These are logs for my machine learning that I've already created. You might not see this directory if you haven't created a logs folder, but no matter. This is very similar to what you should see. The data sets here, this is a read-only directory. I'm just going to make this a little bigger. You'll see these folders. These are where the data live. You can take a peek at any of these. I'm not going to go too far into it because it can take a minute or two to load if there's a lot of files in the data set, and in many cases there are. Let me, while we're looking at this data, let me go ahead and take a look at the docs page, docs.nightingalescience.org. And this docs page is all the documentation for each of these data sets. So you should see, over here you have these names, and then over here is a little more human readable kind. And hopefully you can figure out, we're working on making this a little easier to parse, but hopefully you should be able to figure out which data set corresponds to which documentation. So for the purpose of today's demonstration, I'm going to be looking at this breast cancer PSJ path, so this is breast cancer, Providence St. Joseph Health pathology. And this is the data set we're going to be working with. This is also the data set of the machine learning competition that we're hosting now. So just here's the data. And then going back to the docs tab, we can see under here we have identifying high-risk breast cancer. We have, I think, pretty good documentation. So we describe the problem, the data set overview. This is all in English, and some data set details, some key variables. So we have lots of info on the data set, as well as a more technical data dictionary, which gives the file tree, which gives each of the CSV files and what's contained in them, gives the columns, the description of the columns, and then a sample of what that data type looks like. So yeah, so I would say if you have questions about the data set, I would start by reading the documentation and then proceeding to the data dictionary. So this is just a good thing to keep in mind. And once again, that's docs.nightingalescience.org. Okay, going back to the platform, I'm going to go back to the home directory. I'm going to open up this tutorial notebook. This is a notebook that I have prepared to show how you can inspect some of the data and do a simple machine learning model, as well as import libraries and do all the things you'd really want to do with data modeling in Python. So in the interest of time, I've written these cells already, but this notebook is available to you in slightly modified format under your home directory. Then go to datasets, go to start here, and then you have this ResNet tutorial notebook. And this is the read-only version. So just because I'm going to be writing some output, I've copied it and moved it to the home directory. You can also move that to your project folder. Okay, so looking at this notebook, I'm going to give a brief tutorial. As I said, the point here isn't to understand or focus on every line of code. It's really just to understand that using our platform should feel very familiar to you if you've used Jupyter Notebooks before or you've worked in Python before. So that's really the takeaway, I think. And what I'm going to be doing in this notebook is importing some libraries, loading and inspecting some data, and then training a deep learning model on it using the GPU. And I just want to show off that this is all very easy to do in our platform, and hopefully it should be it should feel very natural. So okay, so we're starting here. I've already got some imports. I'm going to be using PyTorch, and in particular, I'm going to be using PyTorch Lightning, which is the new PyTorch framework that I particularly like. And we're going to be making use of the NVIDIA's CUDA libraries to take advantage of the GPU for accelerating the machine learning training. I'll go ahead and run the cell, and it works. I should say that if there are libraries that are not installed by default, and we're adding them all the time, but if it's the kind of library that you can install with pip, that is to say it's hosted on PyPy, you can install this on our platform or in your project. You just need to have this exclamation point pip and then install and then the name of the library, just as if you were doing it in your terminal. Just don't forget the exclamation point. I'm going to comment that out. So yeah, that's a good thing to note. But what I did here is I just imported these libraries, and then I ran some code. I set up the root directory, so I don't have to keep typing that, and then the root of where the images are. And the output I got is I do see that, as expected, this is a GPU instance. That's a good thing. So we see that there's this Tesla T4 that's a GPU, and we've got about 16 gigabytes of memory, 15 gigabytes of memory. So everything looks like it's working. Okay, the next step, I'm just going to load in the data frames. Okay, no problem. And then now that those are loaded, I'm going to go ahead and just take a look at what we've got. Okay, we see our slide ID, we see our biopsy ID, we see our slide path. And again, this is explained more fully in the documentation, so don't worry if you're not entirely sure what this is. This is just me inspecting the data, and you can take a look at the doc to understand exactly. But just taking a look at, okay, this is the outcomes table, and this looks correct. So okay, great. So we've got this. I'm going to come down here, and I'm doing a little bit of data prep work. So this data set is about predicting cancer, or excuse me, about predicting the stage of cancer. And they have the data that we've obtained in its original format has these fine-grained labels for each of the stages. It has like 1A, 2B, 2A, 0. I guess these are not sorted, but you get the idea. And so I'm just going to write some helper code that turns these stages from these fine-grained labels into integers from 0 to 4, where 0 means no cancer, and 1, 2, 3, and 4 mean cancer stage 1, 2, 3, and 4. And if it's missing, we'll just return a np.nan. So this is just a little data conversion. Okay, the code runs. And then I am going to look at this labels data frame that I made by merging these two data frames. Okay. And so indeed, we see the slide ID, the biopsy ID, the stage, and then the label, which is the same as the stage, but as an integer instead of a floating point number. Finally, I want to inspect one of the images that we're actually going to be feeding into our model. So I'm going to write a helper function to do that. And I'm going to inspect this image. This is just a random index. So let's just see. Oops. df is not defined. Okay, what I need is, labels df is what I need here. Okay, there we go. So we see that we have a labels data frame and the image returns, and this is what a cancer biopsy slide looks like. These are downsampled images. We have the raw images that are very, very large, but we're using this downsampled one, which you can find if you look on the left here, in the datasets directory. So we have this basic downsampling, and then I'm not going to click this because it's going to load all 50,000 images in the file preview, so I don't want to do that. But you get the idea. I'm just going to try another index. There you go. There's another tissue smear, and let's just it doesn't matter. Just inspecting a few of these. Okay, so we're seeing these images. Okay, and now sort of onto the modeling. So I'm going to take the mean and standard deviation for normalization of these images, just from the first 100 images. So let's just do that. Okay, looks like it worked. So we have our means and standard deviations. And again, this is for image normalization as part of the deep learning process. You don't have to understand this for this demo. I'm just doing this because I want to be somewhat correct in how I do this machine learning model. And okay, proceeding, we're going to do two things. We're going to create a data set and data loader. This is to use PyTorch, so this is a PyTorch specific thing. If you're using another framework, you might not have to do this, but I'm using PyTorch in this demo, as I said. Finally, we're going to create this data module, which relies on this dataset class that I just created, as well as this helper function to do a random split of our data. So again, not entirely necessary to understand the code here. Just at a high level, I'm setting up the model in this deep learning framework called PyTorch Lightning. And then proceeding, I'm actually going to specify the type of network that we're using, the type of deep learning network that we're using. I'm going to be using a ResNet 18. You'll notice that I don't have to actually specify gradients or even the specific type of nodes or how many nodes in each layer or the number of layers or any of that. This is all just, I'm doing this off the shelf. This is provided by PyTorch. So that's a very nice feature, and that works well with our platform. So I'm just going to run this cell, and then we have a few other functions that are part of this Lightning module. I encourage you to look at the PyTorch Lightning documentation if you're interested in using this framework. But there you go. So that has run, and then finally, the last thing we're going to do is we're going to train the model. So there's a few lines of code that do that. Hopefully, this runs if I did everything correctly. No guarantees of that, but let's just give it a try. Ultimately, the two things that we want to do, we're gonna run the model, and then we're gonna test it on some test data. And to do that, that's these two lines of code. So trainer.fit is where the model actually, or is when the model actually runs, and then trainer.test is when we test it. And I'll say that I'm not actually going to be doing the full training right here live. That would take a little too long. I've limited it to one epoch, and not only one epoch, but actually considerably less. We're just going to be doing 10 steps of gradient descent. So that is to say 10 batches of data, which I believe I've specified as 64 is the default batch size. Let me just confirm that. Where did I specify my batch size? Yeah, self.batch size. Yeah, 64 is my default batch size. Okay, so batches of 64, and we're going to be doing 10 steps. So yeah, let's give it a go. And okay, it seems to be running. There we go. And you can see here we have our nice dynamic loader here. It looks like, okay, 699 would be the full epoch. So it should stop after 10 if I've done this correctly. Up to 4, 5. You can see our loss function coming out. 6, 7, 8, 9. Okay, it should be on the last step if this is correct. And let's see. Okay, yep. Now we're in the testing phase. So it looks like it's testing our entire test set. That's expected. Okay, and we have an accuracy score, and this is just one way that you can do testing, but it looks like an accuracy score of 23%. Let's just see, how is that relative to our labels? Okay, we have 23% accuracy, and it looks like over half of our labels, 51% of our labels were of cancer stage 1. So this score is considerably worse than if you had just guessed every image was stage 1 cancer. So that's not surprising. We didn't really do a whole lot of work here, and we didn't even train the model for anywhere close to as long as you want to train it. It did much less than one pass through the data, so that's not surprising. But the point here is that you can quickly and easily do deep learning on our platform. You can use GPUs, you can use state-of-the-art libraries. So yeah, it should be pretty straightforward to do if you have any experience with that. So that's it for the tutorial, and if you have any questions, you can always contact us via the help menu in our platform. And good luck with the contest and deep learning. Thanks a lot.